There are two types of friction, static friction and kinetic friction. Have you ever noticed that when you push or pull on an object, it takes more force to just get that object moving than it does to keep the object moving? Why don't you try it? Put a heavy book or your laptop on a table or a desk and start pushing really gently on it. Push a little harder until it eventually starts to move. Notice that once it starts moving, it seems and is easier to move. Okay, you'll see here two diagrams with a man pushing a large box. The first is not moving, and the second is accelerating. Let's start by taking a look at the force diagrams for each one. They look very similar, except that in the second one, you'll notice that the force of this push, this normal force push, is bigger than the force of friction. Okay? This is the force of static friction, and this is the force of kinetic friction. So if we had this box, we have a 100 Newton box and I'm pulling on it. Okay, we're pulling it to the right. If I used a force probe, I could measure both the force I'm applying and the force of friction. We'd get a diagram that looks something like this. And there's a lot going on here, so let's kind of talk about it a little bit, okay? As I pull on the 100 Newton box, static friction prevents the box from moving. If I pull with 1 Newton of force, the 1 Newton of static friction acts to prevent the box from moving. If I pull with 10 Newtons of force, the force of static friction is 10 Newtons and prevents the box from moving. As I increase the force of my pull, static friction increases to match it and prevents the box from moving until it can't match it anymore and the box eventually moves. In the diagram shown here, the object moved when I applied 50 Newtons of force. This amount of force would be different if the box had had a different mass or if the surfaces were different. So there's something that we're going to learn about that's called the coefficient of static friction. It's a value that depends on the nature of the two surfaces. You might have two very slippery surfaces or two surfaces that are kind of rough. The force of friction depends on the coefficient of friction and also on the normal force on the object. In this case, the normal force is 100 newtons, right? The force of gravity would be 100 newtons. So our normal force, all right, because it's not accelerating up or down, would be 100 newtons. The force required to get the box moving was 50 newtons. This is 1/2 of the normal force. So the coefficient of static friction is going to be 50 over 100, or 0.5. Okay? It is simply the ratio of the force needed to move the object divided by the normal force. Okay, so it took 50 newtons to move it and divided by 100 newtons, which is the normal force. And then you can use that coefficient of static friction and you can find the force of static friction by taking the coefficient of static friction and multiplying it by the normal force, which is what we just said. So this is a really useful formula, and I'm going to put maximum here, okay? Because remember, the force of static friction it increases as I increase my applied force. We're talking about the maximum static friction that could be applied before the box is going to move. Okay? Notice that after the object began to move, the force needed to keep it moving dropped. You see that? It dropped down to 40 newtons. Okay? So once I get it moving, it slides with less force required. So similarly, what would be the coefficient of kinetic or sliding friction? So static friction is the friction that just prevents the box from moving, and kinetic friction is the friction that acts when the box is sliding or moving. So what would that be? What would be the force I had to apply? Or the force of friction was 40 divided by the normal force. So the force of kinetic friction is 0.4. Okay? And for two surfaces, the coefficient of kinetic friction is going to be less than the coefficient of static friction. Okay? When an object slides along a rough surface, the force in kinetic friction acts opposite to the direction of the object's velocity. So just kind of summarizing all of this, the kinetic or sliding friction, we'll abbreviate it like that, it depends on the normal force, okay, and on the nature of the surfaces. That's where this comes from, all right? For static friction, very same. It depends on the normal force and the nature of the surfaces. Well, here's just some samples of the coefficients of static friction and kinetic friction. So rubber sliding on dry concrete would have a larger coefficient of friction than on wet concrete. What does that tell us? That tells us it's easier to slide on a wet surface than it is on a dry surface. Okay. If you look at down here, or shoes on ice or ice on ice, those coefficients are a lot smaller, so your forces of friction are going to be a lot smaller. Okay? So let's try an example here. All right. Let's see. I've got all right, give me one sec. A 50-kilogram box, okay, is being pulled horizontally across a floor at a constant velocity. I give you the coefficient of kinetic friction, and it's kinetic friction, right, because it's moving across the floor. So first thing we should do is start with a force diagram, okay? So obviously we've got our force of gravity, and we've got an equal but opposite normal force. We've got an applied force, okay? And we've got a force of friction here. And we're going to call it kinetic friction. And should these two things be congruent? I think they should, because we have a constant velocity, right? Which means that our acceleration is 0 and that our net force is 0. So what's the magnitude of the force of kinetic friction acting on the box? Well, our formula was the force of kinetic friction is the coefficient of kinetic friction times the normal force. Well, it looks like the normal force equals your force of gravity, which is mg, which is 50 times 10, or 500 newtons. So we plug in here our 0.34, okay, we would have gotten that in the problem or from a table, times 500, and we get 175 newtons. So our force of kinetic friction is 175 newtons. So what is the magnitude of the force pulling on the box? Well, we just said that the acceleration was 0 and the net force was 0. And therefore, we said that the force of kinetic friction was equal to the force of that pull. Therefore, it also is 175 newtons. Okay, so we'll do some problem solving using these kinds of formulas and the coefficients of kinetic and static friction.